We're going to dive deep into the architecture that powers pretty much all the AI you use every single day, from chatbots to translation apps. And believe it or not, it all comes down to this one simple but totally revolutionary idea: attention.
But first, let's start with something I know you've felt. You're deep in a conversation with an AI, you've given it a few instructions, and then poof, it just completely forgets something you told it like a minute ago. So why does that happen? Well, to get the answer, we have to go back to 2017.
You see, to really understand why today's AI is so incredibly powerful, but also so frustratingly forgetful sometimes, we have to look at the problem it was designed to solve. And that means looking at the huge limitations of the models that came before it.
So, before this big breakthrough, models like what are called recurrent neural networks, or RNNs, had to read language just like you and I do. One single word at a time. And this, right here, created a fundamental bottleneck. The whole process was sequential, and that was a massive, massive problem.
Think of it this way. The old models, the RNNs, they were kind of like a snail, crawling along a sentence, one word at a time. To connect the very last word to the very first, it had to remember everything along that long, slow, winding path. But the new idea? It was a total game changer. It asked, what if, instead of a snail, you had a rocket that could just see the entire sentence out once and instantly figure out the relationships between every single word?
And this table right here, from the original paper, this is the technical leap in a nutshell. It says it all. With the old recurrent method, the longer your sentence, that's N, the more steps it took to connect the words. The path just got longer and longer. But with self-attention, look at that. It's constant. It takes just one operation to connect any two words. It doesn't matter how far apart they are. That is a fundamental game changer.
So, this breakthrough brings us to the main event, the solution proposed back in 2017 by a team of researchers at Google. They put out this landmark paper with a title that was almost ridiculously simple: "Attention is all you need." And this one sentence from the paper's abstract, well, it was basically a declaration of war on the old way of doing things. They weren't just adding a new little feature, no. They were proposing an entirely new architecture, the transformer, that just threw out all that slow sequential stuff and replaced it with one single thing: attention.
And the architecture itself has this really elegant two-part structure. First up, you have the encoder. Its job is to read and really make sense of the input text, let's say a sentence you type in English. Then the decoder takes that understanding and generates the output, like the translation in German. But the critical part here is that neither of these pieces reads word by word. It's all happening at the same time, in parallel.
Okay, so what is this attention thing anyway? What's the secret sauce that makes the transformer so incredibly powerful?
At its very heart, self-attention is basically like a relevancy highlighter. For every single word that it's processing, the model can look back at all the other words in the sentence and give each one a score based on how relevant it is. And that's how it builds this incredibly rich, contextual understanding of the entire text.
So how does it actually work under the hood? Well, you can think of it like a really sophisticated search inside a sentence. For every single word, the model generates three things: a query, a key, and a value. The query is basically the word asking, hey, who in the sentence is important to me? It then compares itself to the key of every other word to see how well they match up. The strength of that match creates a score, we call it a weight, that tells the model just how much attention to pay to that other word. And finally, it just takes a weighted sum of all the values to create a brand new, context-rich version of that original word.
But, why stop at just one perspective? The transformer architecture takes this whole thing a step further with something called multi-head attention. It runs this entire query key value process multiple times, all in parallel. In the original paper, it was 8 heads, and this lets the model look at the sentence from 8 different angles all at once, capturing all these different kinds of relationships, like grammar and meaning, simultaneously.
And the results? Oh, the results just speak for themselves. This wasn't just some small theoretical improvement. On a standard translation test, the transformer didn't just beat the previous best models, it completely shattered the record. It set a new state of the art, and it did this while training way, way faster. This was the moment that the world of AI really changed forever.
So let's fast forward to today. That revolutionary tech from 2017, it's now inside all the large language models we use every day. But as these models have gotten bigger and more complex, a new, very relatable problem has started to pop up. It turns out that even with this amazing ability to see a whole prompt at once,
These super powerful LLMs, well, they can get lost. When you're in a long, back-and-forth conversation, they start to lose the plot, forgetting key details or instructions that you gave them earlier in the chat.
And you might be asking, just how bad can it get? Well, recent research actually put a number on it. In these multi-turn conversations, the unreliability of these models can go up by a staggering 112%. They become way more likely to just forget what you asked for.
Let's look at a classic textbook example. A user gives a really clear three-part instruction. Hey, please generate X, and I need it to have requirement 1, requirement 2, and requirement 3. Seems simple enough, right?
The model comes back all confident, saying, "Sure thing, here's X with requirement 1. But wait a minute, it completely ignored the other two parts of the request. This is the first sign that it's starting to lose the thread of the conversation.
So what do? You have to prompt it again, right? You have to remind it of one of the pieces it missed. Hey, you forgot something. I also needed requirement 3.
And this is where we see the problem in action, perfectly. The model apologizes, says of course, and adds requirement 3, but in doing so, it drops requirement 1. It's like it's juggling. As soon as it grabs a new piece of information, it accidentally lets go of an old one.
And that brings us right back to where we started. The attention mechanism was this incredible, revolutionary solution that helped AI see the whole picture instantly. But now, the challenge has changed. The big question for the next generation of AI isn't just about seeing the picture. It's about remembering the entire story.